So we have to understand how AlphaGo works, right? And what the developers had in mind when they were making this thing. The key word here, or the key phrase here, is reinforcement learning. Reinforcement learning. It's literally what it is. You're reinforcing yourself with rewards, saying, oh, I like what I did with this, I'll continue doing that. Oop, when I did this, I lost a bunch of points, or I lost this game, or whatever, I won't do that next time. That's this reinforcement. So you have an agent, a person who is understanding this, and there's an environment around that agent. And depending on what the agent does, and depending on what the agent observes, the agent thinks differently. Does that make sense? So right now, it's complex when you talk about a human, but let's talk about a machine, a software. And they wanted initially for this machine to be hooked onto any game and play that 2D space shooting game with perfect precision. So first, when you throw that machine onto that cyberspace where they have to shoot those spaceships, then all it sees is black space as the background, and then moving spaceships at intervals. Does that make sense? And you have a lever that lets you control left or right, and then you have another button that lets you shoot or not shoot. And the machine will try different things. It'll move left, it'll move right, it'll start shooting, and then when it moves left and it dies, it'll realize that, oh, there was a rocket or some sort of missile that was shot by the enemy spaceship, and then when it hit me, I die. So the machine learns that. And it goes that through iterations and iterations. So continue practicing, and every time it dies, like, oh, that happened when I die, so next time let's just move away from it. Or let's start using these buttons and start killing these spaceships so that I don't get threatened by the missiles. So the machine, after dying 100,000 million times, it learns, okay, this is the best strategy. And then they take that out, they plug it in the same way, in a different game, and it will see a whole new feature. Maybe a different background, maybe a different color background. Yeah?
It's like when babies, when they're walking, and then they fall, and they realize that when they walk, they fall.
That's exactly what it is. That's exactly what it is. If you found out that standing in a certain way tips off your balance and you continue to fall, are you going to do that? No, you're going to find a different posture so that you don't fall down. That's the exact same principle. So you're teaching the machine what's a good thing, what's a bad thing, and once the machine knows that, then it will only look for the good thing. It's a reward system. Does that make sense? It's as simple as that. It's really as simple as that. Okay. So then how is AlphaGo made? They say in the documentary as well as the Netflix special, and many, many talks that the researchers came out and did. So they had talks in front of the Royal Arts of Society in the UK. They did a conference with artificial intelligence conferences. So a lot of appearances making comments about these, but mainly comes down to three key components. The data that learns from the value or the value system, right? The learning algorithm that learns from the data, which is called a policy system. And then the search algorithm, which is called the tree search. So you have a separate piece of data that says, this is a good or bad move based on the value, probability. You put it here, it's how many percent. You put it there, it's how many percent. So this is better. You value this more. By making this move, you lost the few rounds before, so this is a negative, bad move. You don't want to make this mistake. Does that make sense? That's a value network. Policy network is, okay, we have all these lessons learned. Now, anytime you're confronted with this situation, this is your policy. This is what you need to do. Every time you're in this board and it's in a pickle like this, something similar, then you use all the stuff that you have in your value network, and then you extract a policy. You say, we will do this in the event that this happens. Does that make sense? Okay. And once that become big enough, the machine needs to understand, okay, where did I put where again? They need to go backtrack and see where they got that lesson learned, what value and what policy. So they need a tree system. So that's the main three components, right? Initially, this is really important that you know, AlphaGo, the version that beat Lee Sedol, had human intervention, meaning that they initially, when they first started out training the machine, they put in human plays, amateur plays, professional plays, whatever. There was human intervention. This is how the humans play, this is how they react to this, this is their policy network, this is their value network. So the humans' play styles were in the AlphaGo system and it learned from it, right? And it still beat Lee Sedol. But the creepy thing that really needs to be said is AlphaGo 0. Remember I told you yesterday that now AlphaGo 0 will beat AlphaGo Master, which has beaten AlphaGo Lee, which is the version that Lee Sedol won. So Lee Sedol knows now that he got really lucky with that one game, but in future games, it's very unlikely that he will win one. Unless he pulls off another God's move or something like that. But it's very unlikely. It's very, very unlikely.